So as we discussed earlier, for a linked list like this way, we have a top indicating where's the beginning of the location for the linked list. In order to print it out every single item, we need something to help us walk through one by one. But top is a variable that stores the beginning of the linked list location. So we would not going to change its location at all. So what we need to do is that we need to create a temp address in the beginning equals to top, and then use the linked list address to walk through each item. Let's take a look of how we will be able to do that. So you can see that after we printed out the first item, we will move to the next location. So the temp will store the address of the second item and then keep moving like this way. And let's take a look of the code. The code is surprisingly simple. The printed out function is going to define by this 5 line of the code. In the beginning, like we mentioned, we're going to define the new temp pointer. And we make temp equals to top, indicating where is the beginning of the location. So you can see that in this example, we use the example that we see earlier, top equals to A, indicating the address for the first location is at A address. So 9 is going to be our first item. So take a look at this one. When we try to make temp equals to top, temp is located at the A address as well. As long as temp is not null, and since temp is at the address of A in this example, it is not null. So what we will do is this. We're going to see out, print it out the value that we want to print it out. And this is something new for you to learn. Temp is at address of A. This address contains 2 parts. One part is called the data part. The other part is called the next part. In order to access the data part or next part, this is the special sign that we will use in linked list to retrieve the information we need. So you can see that if we do count, see out temp to the data part, and we will be able to output the value of 9. That is how we would be able to look into the item and then output the item, access the item, change the value. That is the special sign that we're going to use. After we printed out the value of 9, we know the next address is going to be at 2. So what we were going to do is make temp originally at A address now equals to the next address. So the next address 2, basically when we assign temp equal to the next address 2, it will be able to move into here. And then since that is not null, we will be able to output a value of 17 and then goes to the next address. I do prepare the slides, the detailed slides to look into this one. So let's take a look of this. The same thing, I'm going to put the code on the left side, and then we will be able to use the example to navigate us to see what's happening. In the beginning, temp, we create a node of temp equals to top. So temp equals to top equals to A. So since temp is not null in the loop, it is not null, temp is A. So we output the value of 9 through cout temp to the data part, and then make temp equals to the next part. So temp equals to temp to the next part. And that's what's happening for the first 4, the while loop. Now, temp is equals to 2 now. So this is not null, so we will be able to output temp to the data part, which is 17, and then goes to the next part, which is 7. So in the next case, temp is at 7 now, so it is not null, and therefore you output the value of 22, and then temp equals to temp to the next, which is 6. So when temp is equal to 6, what you will see is that it is not null, it will output the value of 26, and then temp equals to the next part, which is 0. So temp is at the 0 at this loop time. Since temp is not null, because it's 0, it will output the value of 34, and then temp equals to the next part, which is -1, indicating this is the end of it. When temp is null, you can see that this while loop is breaked, and then it has nothing followed by that, indicating that it's the end of the program. And therefore, you will be able to traverse every single item in the linked list by providing a top address, and then you will have a method to walk through each items one by one. That is the basic idea of the linked list. At this stage, you are equipped with the general idea of what a linked list is. And I want to make you guys do some practice. So I give you an assignment. Take a look of this one. This time memory is, there's much more things inside of the memory. And not necessarily all of these are related to the linked list I want you guys to look into. Because in your memory, it can be operating system, like your Windows, like your Word, like your PowerPoint programs, and that occupy some memory spaces. So not always all of these are important or related to the data that we are looking at. So the assignment is this. Please show the output of the traverse function applied to the following memory space. So this is the memory space that we have. It tells you the top as at the address of 2. And if you run traverse program, what is the output of this traverse? So I'm designing this one as the assignments. Please submit this on time. And in our next slide or next video, we will look into how do we do the insert operation, as well as how do we do delete operation in the linked list implementation for the lists. Once we finish those two functions, then basically we have finished the list implementation through linked list.